So hi guys, so today we would be looking at the part 2 of the main challenges of machine learning and bad data. I told you in the last video that there are two major things that can go wrong in a ML model, that is bad algorithm or bad data. So we already talked about bad data part 1. So now we would be talking about the bad data in more detail. So in the last video I told you about the insufficient quality of training data. So we would be starting off with the non-representative training data. So here you can see in this line, I would show you that example, but before that I would just give you a brief introduction. What is am I talking about the non-representative training data? So in order to generalize well, it is crucial that your training data must be representative of the new cases you want to generalize. There should not be any bias in the training data. You can see here that the bias that has caused by any particular data has led to the non-representative training data. So I would just give you a very famous example. This example is of US presidential elections in 1936. So what happened is, there was this prediction house which collected data from all of from 5 million people in USA, and told that the B party is going to win with 63% votes. So according to it, the B party is going to win with 63% vote. But after the elections were announced, this B party won only 37% of the votes, and the opposite thing happened. The A party won with 63% of votes. So how did this happen? So the prediction was predicted well according to the data present for it, but the data which was taken by them, the 5 million data, out of the 5 million users predictions, their opinions, out of that 2.9 million data was of people who were from really from high class background, that the people who were really rich, and then 1.3 million data was from medium class people. It was from the people who were from a middle class background. So it's obvious that they would vote for B party according to that timeline. And it took only data of poor in a very few quantity. Means you can just add up, that is 2.9 plus 1.3 is equals to 4.2. Means it only took 0.8 million data from that of the backward classes and poor people. From that we have got an idea that why the data became the most efficient reason of the predictions going wrong. Hence there should not be any bias in the data. This is often hard. If the sample is too small, you will have the sampling noise, but even very large samples can be non-representative if the sampling method is flawed. So this is called basically sampling bias. The US presidential elections was the best example in this sampling bias. Now coming to the part, so in this from this part, what we got to know, that there should not be any bias in the training data. The equality should be maintained throughout. Now coming to the next part, that is poor quality data. So suppose if your whole data is full of errors, the outliers and noise, it will make it harder for the system to detect the underlying patterns. Now suppose this is your data and this is the prediction you want to make. Suppose yeah, and these are the two features. Now A person has these two features, B has these two features, C has this, and D has these. Now suppose A have both the features, B have, now C doesn't have this feature, only this feature, and D only has this feature, not this feature. So this makes it hard for the model, in which the data is anomaly filled and is not completed, for to make some predictions regarding the corner cases and even the normal predictions. The whole factor of machine learning is to provide good data so that the model can train on the actual results. So it is often well worth the efforts to spend the clear time cleaning up the data. So the actual truth regarding machine learning, some people think that machine learning is all about training models and all. Big data scientists put most of their time in cleaning the data, making the data more good, and they spend a significant part of time doing this only. So machine learning is not only about training models, but also about making the quality of data good and better for the model. So there are basically two methods to clean data. So the first method is manually search for the errors, just like we did in the previous one. We manually searched for the errors and fixed it. Else we can use some anomaly detection. So many frameworks like TensorFlow Extended and SQLite would provide you the option to anomaly detect the data that has been different from the other data. So that is the point of anomaly detection. Now coming to the last part, that is irrelevant features. So the feature selection part is a very important part when you're making your whole data. So while selecting the features, if we have to remove the irrelevant features, and we have to increase the performance of our model. So your system will be capable of learning if the training data contains enough relevant features and not too many relevant features. A critical part of the success of an ML project is coming up with a good set of features to train on. So what happens is, suppose I gave you this the data, and it had some more data here, and only suppose we have three more features, and only two out of the two these features are relevant, the rest three are irrelevant. Then there is no use of having these irrelevant features. It would only make the predictions of model go wrong. Now suppose these are the four relevant features, and there is one irrelevant feature, then it can work. But your main aim should be removing all the irrelevant features. And the feature selection, selecting the most useful features to train on among existing features. Now feature extraction comes to play, combining existing features to produce a more useful one. Like I could have chosen those two features and combined them to create one useful feature, or we can create new features by gathering data depending upon the amount of data you have. And this makes the training faster, it is easier to build, it is easier to understand, and easier to debug. So these are the importance of irrelevant feature removation. So these were the three topics we discussed today. The first one was the non-representative training data, and the second one was poor data quality, and the third one was feature selection. No, and removing irrelevant features. So these all three features are important, and all the three methods are used while making a machine learning model. So I hope you have got an idea what are the main challenges when it comes to bad data part in machine learning. In the next video, we would be talking about bad algorithms, the algorithm part that need to be avoided while you are building a model and training it. So this was it for the video. Thank you and have a nice day.